This is Mac 1105, Section 1.6, Part 3. This is about solving polynomials like this by substitution. They're also called quadratic form equations. And then you got to be sure you check these, and I'll show you why. If the power on the first term is exactly twice the power on the second term, if the first term power is exactly twice the power in the second term, you can think of this equation as a quadratic form, which is important to us because we know how to factor and solve quadratic equations like x squared plus 5x minus 6 equals 0. We know how to factor that. We know how to solve that. We haven't had a lot of experience with x to the fourth or x to the sixth or x to the 2/3, but we can make this a little bit easier on ourselves if we check out that power and that power. As long as the first power is exactly twice the middle power, or from the other perspective, the middle power is exactly half the front power, then you can think about these being in quadratic form, and then they're going to be factorable for us. But before we can just automatically go to a quadratic form, we need to do a little substitution. So we're going to use a different letter. Since our equation is x, we'll say let y equal something. And what we're going to let y equal is whatever the middle term variable in power is. Since that's 8x squared, we're going to let y equal x squared. Don't use 8, don't use the coefficient, just the x squared. Once you've done that, you can get this formula, or you can get this equation to look like this. If x squared equals y, you're looking at negative 8y minus 9 equals 0. And then what is this? This is going to be y squared. Because we've made sure that the middle power was exactly half the front power, that means that this is half of 2 is half of 4, so 8y to the first is half of y squared. And there you go, you have it as a quadratic. You can factor that very easily. Y minus 9 times y plus 1 equals 0. Very easy to solve. We have y equal to 9 or y equal to negative 1. Now what you have to be careful of is that you have solved for y. Our original equation was x's. So we have to take this information and plug it back in here. So y equals x squared. So you write down 9 equals x squared. Y equals negative 1. Write down negative 1 equals x squared. And then you have these equations you need to solve. To solve this, we will undo this by taking the square root of both sides. And when we solve by taking the square root, we have to remember a plus or minus. So two of our solutions are plus or minus 3. Same process over here. Take the square root of both sides, apply a plus or minus, and remember that the square root of negative 1 is just I. So our four solutions are 3, negative 3, I, negative I. And on a test, the plus or minus is just fine. Math Lab doesn't let you use the plus or minus sign, so you have to write them out separately. The easiest way to check this is to use the stow button on your calculator and to do 3, stow as x, and then you just have to type in x caret 4 minus 8x caret 2 minus 9, and that will come out to be 0. Same thing for all these other ones. You can type in 3, negative 3, I, negative I. And to save time here, I will tell you all of those do check, but you can try it with your calculator just to practice with the stow button. All right, this next one is in radical form. These are not exponents right now, so we need to think about converting the square root of x to its rational exponent form, which is negative 12x to the 1/2 plus 27 equals 0. And of course, this stays here, x to the first. Now, is the first power exactly twice the middle power? Yes. That means this is quadratic form, and doing substitution would be a good idea. Let y equal x to the 1/2. And then our polynomial will be y squared minus 12y plus 27 equals 0. Now, it may bother you all of a sudden for me just to plop down a y squared, but that's not really what's happening here. It's the fact that the first power has to be exactly twice the middle power. And we've already established that 1 is exactly twice a half. So since this is 1, 2 times 1 is 2 for y squared. Now we can factor this. Both of these are negative. One of these is 9, one of these is 3, because you're saying what multiplies to give you 27, that adds to give you 12. And that gives me y equals 9 and y equals 3. But I've got to go back to this step. Y equals 9. That equals x to the 1/2. And 3 equals x to the 1/2. Of course, in this instance, you could keep it as the square root, but I'm going to keep the rational exponent right there because we just finished that up. To solve a rational exponent equation, you want to raise it to the reciprocal power, which is 2. So this cancels and gives me x. 9 squared is 81. And same deal here, square both sides. And this gives me x equals 9. And same thing with the checking. You can do 81 stow as x, and then type in exactly what you see right there. X minus 12 radical x plus 27, and it will come out to be 0. So both of those do check. And another comment on this video, I'm doing this a little bit different order than what's in the packet because I wanted to do the easier factoring problems first and then do the two with the coefficients last, because those are just a little bit harder to factor. So for this one right here, is the first power exactly twice the middle power? Yes. 2 times -1 gives me -2. That says yes, we can think about this being a quadratic, which says, let's go ahead and do our substitution. Let y equal x to the -1. Remember, you're always going to make the substitution so that you're using that variable with its power as the substitute value. And once we have made that substitution, we just have to create our quadratic equation that we can then factor and solve. So since y equals x to the -1, I will put y right there. Minus 20 equals 0. What power will this be? This will be y squared because our middle power is exactly half of the front power. Since this is 1, this had to be 2. Then we're ready to factor this. This is y with a minus and y with a plus. The signs have to be different because the last term is negative. This will be minus 5 plus 4 equals 0. Solve that equation. We get y equals 5 or -4. And remember, those are the y values. We are not finished. We have to go back and stuff them in here to solve for x. So the first one will say 5 equals x to the -1. And the other will say -4 equals x to the -1. Remember, your negative exponents are equivalent to fractions. So x to the -1 converts to 1 over x to the first. And I'm going to write 5 as 5 over 1 because I like to cross multiply. This will be 5x. 1 times 1 is 1. Divide by 5, and I get x equals 1/5 is one of my solutions. Same process over here. X to the -1 is 1 over x to the first. Give this a denominator and cross multiply. So x equals -1/4. And to save time, I will tell you they both check, but you can stuff that in using your stow button on the calculator. Now the first three we did all had just x to the third to begin with, or x to the fourth, or x to the 1 without a coefficient. These problems here are going to have coefficients, and they're a little bit harder only because the factoring is a little bit more involved. So I have to first off look at this and say, all right, the 1/3 is exactly half the 2/3, which means I can think about doing a substitution. So let y equal x to the 1/3. And then my polynomial will be 5y squared plus 11y plus 2 equals 0. Now, whatever way you want to factor this is up to you, but what we have been using in class is the divide and slide method. So to do divide and slide, we're going to go over to this little blank space over here and create a new pretend easier polynomial. And that is, it goes y squared plus 11y, and our last term is 5 times 2, which is 10. Do not put equals 0. It's not equal to 0. It is just a new made-up polynomial that's easier to factor. This factors as y plus 10 times y plus 1, because that 10 times 1 is 10 and 10 plus 1 is 11. We're not finished with this. Remember, we created this pretend polynomial by multiplying 5 times 2. So we need to go back and divide by 5, divide by 5. This comes out even, so this is y plus 2. This does not divide out, so we slide that in front. And that right there in black is the correct factorization for my blue polynomial. So this is y plus 2 times 5y plus 1 equals 0. Notice there was no equal 0 with this. This was just a little pretend polynomial we used to make the factoring easier for us. Now we can set those equal to 0 and solve. Y is negative 2 or y is negative 1/5. Those are the y values. You need to stuff those back up here and solve. So the first one will be negative 2 equals x to the 1/3. And the other is negative 1/5 equals x to the 1/3. Now, because that's a rational exponent, you can do either, it's your choice. You can leave it as rational exponent and raise both sides to the third power, which is what I'm going to do. Or you could convert back to radical if that's what you want to do. So raising both to the third power, this just gives me x, this gives me negative 8. I'm going to do this one as a radical just to show you the difference. This stays negative 1/5. X to the 1/3 is also known as the cube root of x. To undo the cube root, we do the opposite, which is cube both sides. Notice, no matter which way you think about it, to solve this, we had to cube both sides. Negative 1/5 cubed is negative 1 over 125. So those are my two solutions for x. And they both do check. You can do stow, but if you're going to do stow, let me just go over some parentheses for you. If you do negative 8, stow as x, and then come back and type in your polynomial 5x caret parentheses 2 divided by 3, because that exponent is a fraction, plus 11x caret parentheses 1 divided by 3, and then plus 2, and that works out to be 0, and then this one also works. All right, like our usual equations, everything's got to be on one side equal to 0 to be able to factor and solve. So my first step here is 3x to the 1/2 plus 5x to the 1/4 minus 2 equals 0. All the other ones that we did on this page were already in the correct form to be able to factor them. Take a look at your first power. Is it exactly twice the middle power? Yes, 2 times a fourth is a half. So that says, yes, I can use my substitution. Let y equal x to the 1/4. And then my polynomial will be 3y squared plus 5y minus 2 equals 0. And it's like the last one in that we've got a coefficient in front of y squared, which makes the factoring a little bit harder. So we're going to go over to the side, make up a new polynomial, and create this new polynomial, which is y squared plus 5y minus 6, not equal to 0. It is just a polynomial that I'm making up. And where it comes from is we're just dropping the 3, but we're using it to create that 6 at the end. This will factor as y. One of these is plus, one of these is minus because the last term is negative. And you're saying what multiplies to give you 6, that subtracts to give you 5, which has got to be 6 and 1, not 3 and 2. So that's the factorization of my little pretend polynomial, but we're not finished with this. Remember, we created this little pretend polynomial by dropping the 3 and multiplying to make this 6. So we've got to go back and divide by that 3. 6 divided by 3 comes out nice and neat as 2, but we have to just slide the 3 in front here. So this red factorization is the correct factorization for this polynomial over here. Y plus 2, 3y minus 1. Then we can set each of those equal to 0 and solve. So we have answers of negative 2 and positive 1/3 for y, but that's just my y answers. I've now got to go back to this step and kind of unsubstitute, if you want to think about it that way. Put negative 2 in for y, and that equals x to the 1/4. Over here, you're going to put 1/3 in for y equal to x to the 1/4. Now, because this is x to the 1/4, we will raise it to the 4th power. Negative 2 quantity to the fourth power is positive 16, and this is x to the first, or just x. I'm going to come back to that one in a second. I just want to finish this one out over here. Same thing, x to the 1/4. I need to raise it to the fourth power, which gives me x. And then 1/3 to the fourth power is 1/81. Now we've been talking about checking. If you were to check with this 1/81, it works. And again, you're going to type this as 3x caret parentheses 1 divided by 2 plus 5x caret parentheses 1 divided by 4. And then when you hit equals, because this is equals to 2, it should work out to be 2. Before that, of course, you would have done 1/81, stow it as x. If you do that same stow with the 16, it doesn't work. Now that's why we check all the time, because sometimes something doesn't work. But let me show you why that doesn't work, and that you might now pay attention before you get to that spot and you know that it's not going to work. Back here when we had negative 2 equals x to the 1/4, I could think about this in its radical form instead. This is the 4th root of x equals negative 2. Hopefully right there you look at that and go, wait a minute, something doesn't look right. And what doesn't look right is the fact that when you take the square root or the 4th root, whatever root of x, it comes out positive. That's what's known as the principal square root. This doesn't happen. The 4th root of some number does not equal negative 2. Right there you know that that answer is not going to work. But if you'd gone all the way through here and you've gotten 16 because you did some correct moves, do the 16 stow as x, and type it in, it doesn't work. So the 16 gets thrown out, and we keep the 1/81.